A professor demonstrates the Doppler effect by tying a 600 hertz sound generator to a 1 meter long rope and whirling it in a horizontal circle above her head at 100 rotations per minute, or RPM. What are the highest and lowest frequencies heard by the classroom? So I've already listed out all the known variables, which are the frequency of the source, which is 600 hertz, or seconds to the -1. The radius of, like, where the professor is versus where the sound is being generated. Sound is going outward, is 1 meter. And then the velocity of sound, as we know, is 343 meters per second. And then the angular velocity is 100 revolutions per minute. Oof. So the first thing we need to find is the velocity of the source, but not the angular velocity. So we do that by taking 100 revolutions per minute, and we can multiply that by the radius, which is 1, which is very simple. And then we will multiply by 2 pi radians for 1 revolution, and then multiply again for 1 minute every 60 seconds. And then that gives us 10.5 meters per second. That equals V sub s. So now that we have all our variables, we will use the Doppler equation, which is F0 over 1 minus V sub s over V. So we do 600 hertz over 1 minus 10.5 over 343. And then the meters per second on both of these cancels out, and that will give us 620 hertz. And that is for when the speaker is traveling towards the classroom. Now for when the speaker is traveling away from the classroom, like back towards, let's say, the chalkboard or blackboard, whatever, we will get F0 over 1 plus V sub s over V. Same exact numbers will be plugged in. Minus 10.5, 343. And again, those units will cancel out. And that will give us 580 hertz for when the speaker is traveling away from the students.